Many of you ask several times, when am I ever going to use this thing or that thing when I'm doing something in math class? You know, I'm not going to be a math teacher. I'm not going to be an engineer. I'm not going to be an accountant. When am I going to actually have to deal with something? There are a lot of different places in life where you're going to be dealing with numbers in different ways. It may be when you're doing some project around the house, some carpentry stuff with carpeting or tiling or painting something. It may even be as simple as going to the grocery store and trying to figure out in a multi-pack what's the better deal, if I buy 3 at once or 12 at once. Because sometimes just because you buy more doesn't necessarily mean you get a better price. So what we're going to do is we're going to take a little look at how to deal with some conversions and ratios with things. A lot of the time, basically, it's just doing some division. But getting an idea of how the labels work with things can also help us when we're in a situation having to look at something per square foot or per pound or something like that to actually understand what we're getting and not just go in, kind of blind. So, ratios, again, compare two numbers. 180 yards and 12 carries can be written as 180 divided by 12, which is 15 yards per carry, okay, when we go ahead and divide something out. So, as we go through here again, odds are going to be the notes. We're going to work through those. So, 1,000 millimeters in 1 meter. Now, this one's a little strange because normally we're not dividing by 1. But it's important when you're doing these to put all of your labels. Because then when we do a unit rate and we say that there's 1,000 millimeters per meter, that one looks kind of strange. Okay, we'll get to some more here that aren't quite this odd. 3 feet in a yard. Okay, so 3 feet, 1 yard equals 3 feet per yard. Now they're not all going to quite be this simple. Okay, here's a better one. 200 miles in 4 hours. Well, what's 200 divided by 4? Well, that's 50. 50 miles per hour. See, they haven't always just had things on cars where you just sit there, oh, I'm going 65 miles per hour. What the vehicle is actually calculating with that is, how many miles would you go over a 1 hour period if you kept this pace up? It's not just, some fancy schmancy way of doing things. So as we keep working down, 20 minutes for $5. Maybe you go to the chiropractor, get a massage or something like that. So 20 minutes divided by $5. Now what happens if I get something that is so let's see, 20 minutes for $5. 4 minutes per dollar. Okay? A lot of times this would be written the other way, $5 for 20 minutes, but we're going to go with the way they do it. So 4 minutes per dollar is what I would be looking at. Okay, 28 days and 4 weeks. It's always the first over the second. 28 divided by 4 is 7 days, and our label on the bottom always goes on the bottom. So nothing too terrible, okay? Now sometimes, though, what if we need to start changing things? Well, what do you mean? Well, what if I have a problem? Okay, it talks here about reciprocal rates. Why would I need that? Well, maybe I want to turn minutes into seconds, or hours into minutes, or dollars into cents sometime, and we'll get into that. So here, when we talk about a reciprocal rate, it just means we're going to flip it over. Sort of like when I was talking about, we'd normally say this is instead of $5 for 20 minutes, it'd be 20 minutes for $5. Same idea. You're like, oh, there it is. Okay, right here with those. And let me even give you 8. A little sneak preview since you're watching this online. If I put $5 over 20 minutes, okay, I'm going to do 5 divided by 20. Now you'll notice I don't get the same answer. You're like, ooh, 0.25. What's that mean? Means it would be 25 cents per minute. Same information, but depending on how we want it written, it changes the way that we're going to write our label. We know there's 24 hours in a day. There's 1 day and 24 hours. There's 24 hours in 1 day. Okay, oops, I just gave you a freebie, so I'm not going to give you the last one. I'm going to leave it. Okay? So when working on an addition problem, the labels have to be alike. But in multiplying, they do not have to match. So like, this is going to be interesting. For instance, here, when we're multiplying, we're going to kind of blend in a couple of evens here too. 3 men in 8 hours. Well, 3 times 8 is 24. And you combine the thing, okay? So we have 24 man hours. Okay, here, 6 feet and 10 pounds. They don't go together. Okay, they have to be the same label. So that's kind of tricky because this just stays the same. Okay, so things that are alike can be multiplied together. For instance, here, not like terms. I can't do anything else with them. Here, I can multiply them together. Okay, it's kind of strange, I know. But yeah, when you're multiplying, you do not have to match. You can go ahead and multiply them. But again, if you're adding, we can't do that. So let's take a flip over. So let's take a peek as we get to the back to see what's going on here, okay? Now, complete by canceling numbers and their labels when you're able. Now here, you have choices. Let me show you both ways on number 25. Some of you may find it easier to just multiply across. 6 over 10. And then either use math enter if you have a calculator. Maybe some of you have a fraction reducing button. Or maybe you'll just look at this and say, hey, I can divide each of these by 2. Or let the calculator let you try and help figure it out. 3/5. Well, what's my other option, Mr. H? Glad you asked. If I take the same two values, what I also can do is say, you know what? Those 2's are the same. I can cancel them. And then I'm left with 3/5, and guess what? I got the same thing. Okay? So if you can figure out ways to reduce, that can help. If not, not a big deal. Okay, again, here, I'm even going to give you 28, another online bonus. Is 3 going to 5? Nope. Can 8 go into 16? Yes. Once and twice. It may not go in evenly to both every time, like here the 2's canceled, but if something goes in partially, then I can just multiply across. Otherwise, if I multiply it across the original problem, I'd get 48 over 40. Okay, if I'd have done it the original way, and just multiplied straight across, I got 48 over 40, but then I'd have to know that 8 divides into both of those. Same answer. So we're just kind of trying to get a feel for this. Now, sometimes it may work for both. For instance, in 29, how many times 5 go into 25? 5. How many times does 3 go into 9? 3. We get 5. 1 times 3 is 3, and I'm done. Okay, keep life simple. Keep it simple, keep it simple, keep it simple. Then you're like, ooh, now we're going to start getting into letters and stuff. I'm not sure about this. Treat the labels just like you would a variable, so like 31, for instance. Okay, miles and minutes are different, but hours are the same. They can cancel. So I'd have 50 miles over 60 minutes, but what goes into 50 and 60? 10. Basically, we can just dump the zeros. So 5 miles every 6 minutes would be a pace that I could run. Okay, it doesn't have to get down to 1 on the bottom. We can still reduce things that way. Okay, on 33. What labels are alike? Let's cancel those right away. Okay, quarts. Anything else? Pints. Okay, and I don't see any numbers that'll cancel because, again, I can cancel to the top and bottom. I can cancel diagonally, but I can never cancel side to side. So 3 times 2 times 2 would be 12 cups per punch bowl. I can get 12 cups of my liquid, my punch, out of the punch bowl. again, with labels. And sometimes businesses have to do this to figure out, if they're booking a party for 50 people, they figure out, how many ounces per people, and then how much do we get out of a container, and they have to do all this math. This next one's just kind of funny. We got bleeps. Bleeps the same. Hopefully I don't have to bleep too much during this video. Seconds. Again, they don't even have to be right next to each other. They can cancel. You're like, Mr. H, this number's going to get kind of big. Again, let's cancel what we can, though. So, for instance, how many times 2 go into 10? 5 times. Okay. How many times does 5 go into 60? Oh, I can use the same number twice? Absolutely. Do the calculator if you need to. You're like, well, Mr. H, I like 6 into 60 better. Okay. So 6 goes into 60 10 times. Right, but wait, Mr. H, there's another one. Okay, now what? 5 will go into 10. Okay. 5 goes into 10 twice. Dang, that's a lot of canceling, Mr. H. Yes, it can be, but it's going to make this a lot easier to work with. So now if I multiply across, 52 times 1 is 52, times 2 is 104. And these are all ones, that's cool. So pops, and the only label I got left down here is minutes. You're like, well, what if I don't see all that right away? Well, if you're using the calculator in class, you could just multiply across with 30, originally with 52 times 2 times 60. Okay, if you don't cancel, you'd have 6,240 pops over 60 minutes, and then you just divide those into each other. And you'd still get 104 pops per minute, but sometimes that's going to be a lot harder than just canceling. So I'd really suggest doing the canceling thing. Let's bump up a little bit here. Excuse me, my table's not cooperating as well as I would like it to be here. Alright. Again, cancel what's alike. I'm looking at this one going 40 over 60. Oh yeah, I can do 10 on each of those. So 4 degrees per 6 seconds. Boom. So again, it's pretty simple. Cancel the like labels. In this case, just multiplying across is all I can do because there's nothing I can do to cancel anything. $256 per week. So you can even use it to figure out rate of pay. Okay, miles, hours. It's 40 going to 3,600. We can try 3,600. Oh, it goes in 90 times. All right, 1, 90. 5280 divided by 90. Not evenly. Okay, so here's where I'm at right now. I'm at 5,280 feet over 90 seconds. Now, that doesn't go in evenly. I get this decimal, and I'm not going to write down 58.6. It's silly. So, what if you try 5280 divided by 90? And at the very least, you could try math enter if you have one in class, which would be 176 for 3. Okay, so if we just wanted to go to decimals, we'd be able to do that right off the bat, but we want to kind of keep going with reducing fractions now. Probably at this point we have gone on to the next day of this, but we're going to put all this lesson together, even though it's a little bit longer. So if you missed either of the days, I'll be putting this on the website to try and help out that way. Multiply the fractions, connect the answers in order in the maze, try to get out. Well, we're not going to do all of it because we're only doing the odds. We know the 5's cancel. We know the feet cancel. What's 2 divided by 6? 1/3. And I'm not going to connect anything now because, well, I didn't do the first one yet. But as you start to see, what cancels here? 2 and 7? No. 3 and 6? Oh yeah, that goes in twice. Anything else cancel? Oh yeah, the x's. Okay. And you kind of start to see where we're going with this. Okay. I'm going to skip down a little bit. We don't need overkill on those. So complete each equation. You're like, what? And here's how this works. For instance, in 55, I want to get to the end where miles and hours are my only labels left. So let's do that first. If that's what all I want to be left, let's look. The seconds cancel. Well, I don't want feet. I want that to cancel. So where would feet have to be so it cancels? Right here. Okay, I want the hours. That's good. But I want miles. I don't see miles anywhere. This last one's going to have to be miles. So I'm going to have to know how many feet there are in a mile. Like, oh boy. 1 mile is 5,280 feet. Now my feet cancel. And look, I got miles up top. Got hours down below. And now I've got to start reducing. Now again, in this case, maybe you multiply across and get that big old number. So in this case, oh, but we don't even have to worry about that. But let's double check. If we take 1,100 times 3,600, that is 3,960,000. And divide by 5,280, amazing, 750 miles over 1 hour. So you don't have to be the math expert here. You just have to set up the labels. Gymnast. I want the gymnast to stay. Team. I don't see team in my answer. So team's going to have to go up here. So those cancel. 8 times what gets me to 32? 4. So what do I want down here? Well, I want meat. 8 times 4 is 32. I have gymnast. 1 times 1 is 1. I have 1 meat. I'm done. So you're sort of starting to build in how this is going to work. 59. By gallon. So I get to just do this one. $1.35 divided by 28. You're like, okay, Mr. H. Now, why are you going to go ahead and do a decimal this time? That's a good question. Because we're talking in decimals in the problem. All the other ones where we just canceled and kept the fractional parts of things didn't have decimals involved. If you have decimals, you've got to have the decimals involved. Nice job on this. Keep working at it. We'll be working on this in at least a couple of days in class, so good luck.